Figure out the things you know.
Yeah.
Okay, so what are things we know? We know that 25 of the pizzas were cheese. Does that mean the at work, not at work, or the total?
Total.
Total, so fill that in. What else do we know? 19 had one or more toppings. Again, is that at work, not at work, or the total? Total. Fill those in. Figure out what else you know. You know that 14 of the cheese pizzas were at work. 11 of the pizzas with one or more toppings were at work. After you have those 4 things filled in, you can find everything else by addition or subtraction. Okay. So it looks like people have all these things in. You have 25 there, 19 there, 14 at work, 11. Now, how can I find this part here? Subtract. 25 total, 14 were at work, so how many were not at work? 25 minus 14, which equals 11. And then this would be 19 minus 11, so that equals 18 there. And then just add them up to get your totals. Uh-oh, that's not right, that's 8. My bad. Okay. Okay, all good? So the last question is, what's probably a cheese pizza not eaten at work? See, cheese, not at work, that's this. So 11 out of 44, which you could leave like that, or they're probably going to just simplify it to 1 out of 4, or 25%, most likely. Okay. Good. Do you guys need 15 seconds with your neighbors for this?
No.
Okay. Next, compliments. Alyssa Q, read.
The complement of an event E denoted by E is a set of outcomes in the sample space that are not included in the outcomes of the E. Everything that is not E.
Right. It's either E bar or E E with that superscript of C. The nice thing about it is probability of rain plus probability of no rain has to equal 1 or 100%. Probability someone has brown hair plus probability they don't have brown hair has to equal 100%. If you add every probability of an event plus its complement, probability of its complement, you better get 100%. Because either you are or you aren't, right? The nice thing is if we kind of flip her back around, we know the probability of something, we can just take 1 minus the probability of its complement, which is what we did last class with the ice cream. Right, I said if 23% prefer vanilla, what's the probability you pick someone and they don't prefer vanilla? You just take 1, subtract that, right? Or 100% minus 23%, 77%. So let's go ahead and bust out your, I know we still have some quiz stuff to go over, but bust out your notes from chapter 4. And we're going to go to lab problem number 5. That is top of page 4. Hey, so flip back to page 3. Did you guys fill in everything on page 3? All the notes? No? I'll give you the first 2 because we went over that kind of quickly last time. The top one on page 3, given. Given means you know event A has occurred, right? And the one right below it is observational or experimental probability. For the rest of these things we just went over, I'll flip back to the last one so you can fill it out. But as soon as you're done with that, start in on lab problem 5 on the next page. So here's your complement stuff. Do lab problem 5. Yeah. Yeah. Anybody need an extra copy of the chapter 4 notes?
Professor, can I get one too? I'm sorry.
Okay, so let's move on to, these are all in the Canvas notes. If you don't have them down yet, you should get them there. Lab problem 5, top of page 4. I have a box. Eyes here, guys. I have a box with money in it. A $1 bill, a $5 bill, a $10 bill, a $20 bill. Just one of each. I draw one of them. What are my possible outcomes? What could I possibly draw? 1, 5, 10, or 20. So that should be your outcomes, right? Your possible, that should be your first decision you make. From each of those, you don't replace it, you keep it, you draw another one. Right, so you have a second draw off of each one of those spots. So go ahead and take a couple minutes, make that tree.